Assume that we are working for a company or a startup, and in that startup there is one employee which is talking on phone, another who is busy in makeup, and there is someone who is reading one book, and one employee is doing all the work. Think about it, what's wrong here? Here the baby boss has done wrong rerouting of the task. By the way, Baby Boss is a very good animated character movie that you can watch on Amazon Prime, I think. Go watch it, you will love it. Coming back, what our Baby Boss has done, he has sent all the tasks to this particular employee. What he should have done ideally, he should have transferred task related to marketing to this person, task related to graphics design in this person, but only one person is doing all the work. So if we say the baby boss is load balancer, he has to send all the tasks or requests to these different servers. And now one of the server is overloaded. The baby boss or the load balancer is not sending the request consistently across all the servers. We will see in this video how we can solve this problem. Welcome to this video in the system design series, and in this video we are going to learn about consistent hashing. Let's dive in this together. Before we start, I am learning system design using this book. If you want, you can grab a copy of this book from the link provided in description. In this video, we are going to understand what is the usage of consistent hashing algorithm. Why do we need it? Then we will move on to basic rehashing, what is meant by, or what is the meaning of hash space and what are the problems in basic hashing. Then we will move on to the hash ring, the simple one, and then we will add some virtual nodes on the hash ring. After that, we will do a recap or wrap up of this video. Let's talk about where do we need consistent hashing algorithm. It is used in load balancer, caching systems, sharding of different databases, CDNs, and many more. For example, Amazon DynamoDB sharding structure uses the consistent hashing algorithm internally. Akamai, that is one of the CDN, uses consistent hashing to quickly deliver the static content to the end user. Memcached is also using consistent hashing internally. Amazon CloudFront is one of the service from AWS that uses consistent hashing algorithm as well. Let's understand the basic rehashing. Let's say we have one key 0. If we want to hash it, we can convert it to a random number that can be converted back to this particular key. Now this hash number needs to go to one particular hash number. We pass it on to one hash function. Hash function over here is hash modulus 4. If we divide this number by 4, we will get 1. Similarly, there are multiple keys and we are converting them to hash and then doing a mod of 4 on these using the hash function. So this is basic rehashing, which will tell us, okay, this key is kind of saved on this particular node or server. Let's see how it is done. So if we index these keys to server, key 1 is present at server 0, key 0 is present at server number 1, and similarly these keys are present at different servers. So assume that we need to get what is there inside key 3. We will see, okay, we need to connect with server 0. Now we understood what is basic hashing and how our keys are connected to different servers. Now let's say we have removed one server. Currently the server mapping is like this. We have removed server 1. Now what is happening? We need to rehash everything with this hash function. Earlier, if you see closely, the hash function was hash modulus 4. That was the number of servers that are present in our cluster, and then one server went down. We need to update the hash function, and now keys will be remapped, or our hash table should be updated like this because one server has gone down. So this is the problem here. We just removed one server and we have to update almost the whole table, or we need to recalculate the hash table again. The recalculation of the hash table due to removal of a particular server in the cluster causes inconsistency, and we are recomputing the whole hash table. If you see over here, we have to recompute the complete hash table. Let's see how we can improve on this problem, or how we can solve this problem. Assume that we have one space. This is called hash space. Hash space is nothing but the number of servers to which we will map our keys. What if we kind of create a circular ring of this hash space and call it hash ring? Because the modulus operator that we were using in our hash function will do the computation in such a way that this hash space is treated as hash ring. So once we have our hash ring ready, let's put on the servers on this particular hash ring. It would look something like this, wherein we have server 0, server 1, server 2 and server 3. Now if we want to map the different keys to these servers, we can map like this. So K0 is over here, K1 is here, K3 is here, and K2 is here, and K3 is here. Now if K0 wants to find which server it should connect, it should go in the clockwise direction and should connect with the server that we find on this ring. So let's say to find anything inside K0, we will have to connect with server 0. If anything we want to find inside key 1, we will have to connect with server 1. Similarly for K2 and K3. Now on this hash ring, let's say we add one more server. Now when we are adding one more server as for over here, what we have to do, we have to update the location of K0 to K4 and remove the connection between K0 and S0. So on one addition of this server, we are updating just one entry in the hash table. Now let's try to remove one server. When we are removing one server from our hash ring, what will happen? Let's say we removed one server. Now key 1 will try to look ahead when moving into circular path or in clockwise direction. It will connect to server 2 in place of server 1 because it has gone down. So we are just updating one entry in our hash table. Earlier we were updating so many entries in our hash table. This brings a kind of consistency in the hash table that we have. Now let's say we have created the hash ring, but the server placement is in such a way that the servers will not have a uniform load. This is one of the problems that we face when we are implementing consistent hashing using hash ring. Now if we see over here, this particular key will go to server 0 and all of these 4 will go to server 2, and server 3 and server 1 will be of no use. They will not receive any traffic. So to solve this problem, what we can do, we can introduce virtual nodes. Virtual nodes are nothing, they are just references to the actual servers. Let's say we had two servers, server 0 and server 1, but we have created the virtual nodes for these servers and we have randomly put them on the hash rings. Now by introducing virtual nodes, the traffic diversion or the traffic will go to each and every server equally. But in real life situations, what happen, we don't have virtual nodes in tens or 20s, we have them in thousands over the hash ring, so that we have these virtual nodes in thousands in the real-time environment, and these are distributed randomly over this hash ring. So the traffic is divided between all the servers in equal or in approximately in equal. Now coming back to the analogy of our baby boss and his employee. What baby boss has done, he has divided all the tasks successfully equally to all the employees. So all the employees will have equal number of tasks that they are working on, and none of the employee will be overloaded. So mapping this to our hash ring, it would look like something this. All our server 0, server 1, server 2 and server 3 will have the equal number of requests that they are going to serve. So in this video, we learned what is basic rehashing and what is hash space and how do we create a hash ring using the hash space. And we found out there are a couple of problems with hash rings, like uneven distribution of the load that can be solved by introducing virtual nodes on the ring. Okay, from here I would suggest that you explore the use of hash function. What will happen if we use non-numerical keys for a hash function, and how the gateways use hash function or consistent hashing in their design. Okay, so it's a question time. And question for this video is, how will you implement consistent hashing algorithm? That's what we learned in this. So write a pseudocode in plain English and try to Google and understand how this would be implemented in the real life scenarios. You can comment down below and we will discuss the answer of this question in a separate video. That would be towards the end of the series. Okay, so here is a very good quote from John Cleese, and he says, "He who laughs most learns best." So don't forget to smile. Keep smiling, and I'll see you soon with a new video.